Hey everyone, Brian Tomaszewski here. Digital twins are quickly becoming an important data management and representation tool for a wide variety of applications. In the geospatial world, digital twins continue to receive attention for the unique aspects that geospatial content can bring to a digital twin representation, such as urban planning. If you want to learn more about digital twins and how to create one using 3D geospatial data, geographic information system software such as ArcGIS Pro, and Python programming, this video is for you. A definition that I myself and others have used for a digital twin is a virtual model designed to reflect real-world objects. If you've watched other videos on this channel, you know that I have a strong interest in combining geographic information systems, or GIS, with disaster management topics. Disaster management makes for an excellent case study for the development of a digital twin. For example, a digital twin could serve as a complete virtual copy of a city to simulate the effects of a disaster, going far beyond the existing practices of tabletop exercises or traditional 3D models. And to me, that last point about digital twins, that they can go beyond traditional three-dimensional models, is perhaps what is the most exciting thing I find about digital twins creation. In particular, trying to combine some type of real-world sensor into a virtual representation so that the digital twin is a mirror of the real-world entity. And this is exactly what I'll show you how to do in this video using 3D tools in ArcGIS Pro and Python scripting. In this video, I'll teach you how to create a digital twin that is based on a three-dimensional representation of buildings using the ArcGIS Pro software. The color of the buildings will change based on the temperature that is incorporated from a real-time data feed from the National Weather Service in the United States and using a Python script. And before getting into the tutorial, I'll first cover some important background concepts about working with 3D data in ArcGIS Pro. To achieve the tutorial end goal, I'll show you how you can build your specific 3D GIS skill sets each step of the way, that include creating 3D objects from 2D objects, shaping the 3D objects using Lidar data, adding textures to 3D objects, and connecting 3D objects to a real-time weather feed using Python, or more specifically the ArcPy library of ArcGIS Pro. It was particularly exciting for me to develop this video, as I found there were so many ideas that I was not able to include in this video. But I'll provide you with some ideas that you might want to follow up on based on your own creativity about the exciting world of digital twins. It's also important to mention that no Python programming experience is required to follow the steps in this video, as I will provide you with a pre-existing Python code file that you can load directly into the ArcGIS Pro Python window. However, if you do have existing Python coding skills, I will also provide a quick walkthrough of the Python code itself at the end of the tutorial, so you can get a sense of how you may use this code as a basis for building your own digital twins. Lidar stands for Light Detection and Ranging. If you've never worked with a Lidar dataset, it can be a very important source of three-dimensional data. The basic idea behind Lidar is that a laser is used to collect points related to three-dimensional objects. In this tutorial, we are going to use Lidar from a publicly available dataset that I provide you with as a basis for creating three-dimensional buildings. For more information about Lidar, see the link in the video description below. If you're new to ArcGIS Pro, or more specifically three-dimensional data in ArcGIS Pro, an important data format is the Multipatch feature. Multipatch features represent 3D objects using a collection of flat or curved surfaces and patches. Multipatch features are very versatile and can be used to represent many types of things, such as buildings, terrain, and much more. In this tutorial, I'll show you how to create a multi-patch feature based on a two-dimensional dataset that I also provide you with along with the Lidar dataset and Python code file. Finally, again, if you're new to working with three-dimensional data in ArcGIS Pro, it's important to mention the idea of a vertical coordinate system. Vertical coordinate systems are used for height and depth values. One way to think of it, a vertical coordinate system provides the z along with the xy coordinates. As we'll see in this tutorial, I'll show you how the vertical coordinate system is important when creating three-dimensional data. In the next part of this video, I'll give you a hands-on demonstration and walkthrough of the tutorial steps. As a reminder, all the datasets and the Python code file I use in this tutorial, as well as the tutorial instructions themselves, can be downloaded from my website. You can find a link to download all of these resources in the video description below. Task 1, Step 1. Create a new ArcGIS Pro project with a map template. Step 2. It is recommended that you download the tutorial datasets in the same folder as your ArcGIS Pro map project. Assuming you have done this, add building footprints and sample LiDAR into your map. Note that the building footprints have a vertical coordinate system, which will enable this data layer to be transformed into a 3D multipatch layer. Task 2. In this task, you will use the Paste Special tool to copy 2D building polygons that you added to the map in Step 1 into a 3D multipatch object. The multipatch objects will be the basis for the digital twin that you will create later using a Python script. Step 1. Create Scene View. Create a new local scene by selecting Insert, New Map, New Local Scene. This is a three-dimensional view where you will start to construct the 3D representations of the buildings. Keep the default name of the scene, as later in the tutorial, the Python code will be looking for a scene with the name scene. Add the building footprints and sample LiDAR dataset to your scene. Step 2. Create blank multi-patch feature class. Create a new multi-patch feature class and add a text field called name. Ensure that the coordinate system is the same as what the scene coordinate systems are. Step 3. Copy footprints into Multipatch. Select the building footprints and then select Copy, Edit, Copy, Paste Special, and perform the Paste Special into the buildings layer. The two-dimensional building footprints will be copied into the Multipatch layer you just created. You can now make some edits to the new features in the Multipatch layer using the Lidar dataset as a guide. Click Edit, Save to save the modifications you just made to the Multipatch layer. Step 4. Modify Multipatch layer using Lidar. In this step, you will use the Lidar dataset to give you a visual guide for how tall the building should be. Use the 3D navigation tools of ArcGIS Pro to get a sense of how the point cloud from the Lidar is representative of the building shape. To edit the Multipatch feature, select Edit, Tools, Edit Vertices, Select Feature. Select one of the buildings. Select the handles and pull and stretch the shape as need be. If not already, turn on the Lidar to get a sense of the shape of the building. In this next step, we will apply some textures that are provided with this tutorial to make the building look a little more realistic. The textures are images of the building that can be applied to the different faces of the Multipatch. To apply textures, select Edit, Modify, Reshape, Multipatch Texture. Select textures from the datasets provided. Step 6. Refine Shapes. In this step, we'll do a brief exploration of some of the editing tools that are available for a Multipatch feature. In particular, we'll make the building look a little more realistic beyond a simple box shape. Before you start, ensure constraints are active. To begin modifications, select Edit, Modify, Reshape, Edit Vertices. In this example here, you can see how I'm making a simple roof on top of one of the buildings. Remember to always save your work once you're done when you've made any edits. Task 3. Connect Python script into Scene to update 3D Multipatch object in real time. In this task, you will now apply the Python script provided to you with this tutorial to turn your three-dimensional scene into an actual digital twin. As a reminder, the Python script will connect with weather data available on the internet, process the temperature from the weather data, and then generate a color for the buildings based on the temperature. To run the provided Python script, select Analysis, Python, Python window. Right-click on the command line of the Python window and select Load Code. Load the file digital twin arcgispro.py that was provided with the tutorial. Click Enter. Observe the results. Note how the building symbology has been changed. Task 4. Create deliverables. If you're doing this tutorial for a class assignment, you can create your deliverables using this step. To export a scene image, select Share, Export Map, GeoTIFF Map, and in the Export Map dialog that appears, change the file type to PNG. Run the export tool and then retrieve the output image that is generated by this tool to submit it as your deliverable for this assignment. Now that you've seen the process you can go about to build a basic digital twin, I briefly just wanted to give you a quick walkthrough of the Python code that I provided you with in this tutorial. I'm going to show you this code the way I developed it when preparing this tutorial. Note that I'm using Visual Studio Code, where I have pointed my Python interpreter to the ArcGIS Pro Python environment. It's beyond the scope of this video to discuss setting up a Python environment to work directly with ArcGIS Pro. However, please see this video if you would like to learn more about this process. As I mentioned previously, this code was designed so that it could be loaded directly into ArcGIS Pro and run from the ArcGIS Pro Python window. Therefore, I made a point of using libraries that are provided directly with the version of Python that ArcGIS Pro ships with. However, if you wanted to expand upon this script to do other functionality, be sure to update your Python libraries accordingly using tools like pip. The function temperature to RGB is where I think there's a lot of room for improvement. As you can see here, this code was developed to select an RGB color based on the temperature that's received from the weather feed, which I'll talk about in just a moment. Note that I put some comments in here with what I would consider a code challenge, if you wanted to update this to make the colors a better representation. Also note that I actually used ChatGPT to help me write this code, and I would encourage you to start looking into generative AI to help build your Python programming skills, and watch for more videos on this channel on this exact topic. Update symbology is the function that will actually interact with the scene in your map and the multipatch layer. Note that certain lines have been commented out. As I mentioned previously, The script was designed so that it could be loaded directly into the Python window of ArcGIS Pro and run. However, if you look into running the script outside of ArcGIS Pro, note the lines that can be uncommented to run the script. There are also a lot of ideas on how this code could be expanded. In particular, note that I put a mini code challenge in where you could put additional information derived from the weather feed on the layer as it's updated. All the code was designed around data that was received from this particular URL from Rochester, New York. Of course, you can update this to be a different type of data input or perhaps a feed from a different location in the United States or elsewhere. See this website for a list of other weather feeds from NOAA, and I provide a link to this website in the video description below. Starting around line 91 is where the program actually will start once it's loaded in the Python window of ArcGIS Pro. If you've ever done any web programming in Python, you'll notice the straightforward process of using the requests library. In this case, because the weather feed actually comes back as an XML stream once the URL content is retrieved, it is parsed as an XML object. It's actually quite easy to work with this content as the XML is in a very nice, well-structured format. In this example, I was just interested in getting at the temperature. However, if you look at the source of the XML, you'll notice there's a lot of other tags you could potentially grab to update the digital twin in real time. After finding the temperature tag, the code will convert the temperature data from a string format that is received into an integer, and then that integer will be sent to the temperature to RGB function that I talked about previously. The temperature to RGB function will then return the interpolated RGB value that is then passed on to the update symbology function that I also talked about previously. If all of this code works according to plan, you should see the building in your scene update almost instantaneously as the code runs. Of course, like any coding, there are countless ways that this code could be modified, improved, and so forth. And I would encourage you to post any ideas or updates to this code in the comments section below of this video. Thank you for watching this video. I hope now that you have a better idea of how you can go about building a basic digital twin using the three-dimensional data functionalities of the ArcGIS Pro software environment, along with a custom Python script to incorporate real-time data so that your digital twin can reflect the real world. As I mentioned, this is just the beginning, with so many directions you can go in, and I look forward to see what you can come up with in the exciting world of geospatial digital twins. Hi, this is Brian Tomaszewski. If you enjoyed this video, be sure to like, comment, and share this video. Also, please consider subscribing to this channel and clicking the notification icon to stay up to date on new videos from this channel. Thanks for watching.